All right, we're starting chapter 23. We're just going to jump right in. No big changes. We're just going to deal with two groups now instead of one. Resting pulse rates, so you're thinking your heart rate, for a random sample of 26 smokers had a mean of 80 beats per minute. They're going to abbreviate that BPM, and a standard deviation of 5 BPM. Among the 32 randomly chosen non-smokers, the mean and the standard deviation were 74 BPM and 6 BPM. Notice two groups, smoking group, non-smoking group. Both sets of data were roughly symmetric and had no outliers. Is there evidence of a difference in mean pulse rate between smokers and non-smokers? If you are asked about evidence, most people will choose to do a hypothesis test. That's what we're going to do here. We'll do confidence interval in the next video. So I'm going to specify an alpha level. I'm going to call it 0.05. And of course, the first thing I do with hypothesis testing is write my two hypotheses. Since I have two groups, I'm going to need to compare two means. They could either be smokers or non-smokers. Null hypothesis, status quo. There's nothing different between these two. They're the same. Please be really careful in your use of subscripts. If you write mu sub 1, I have no idea what 1 stands for. Then you have to write me a little key. Mu sub 1 means the true mean BPM for smokers. And then you'd have to write mu sub 2 equals the true mean BPM for non-smokers. I don't know about you, that just seems like lots of extra work. So please use subscripts, but use the ones that are really obvious so that you don't have to include this key. All right, you might remember when we did proportions, it was very common for me to write this with a subtraction. That way I was comparing to 0. Either one is fine. You may choose. If you write both, make sure they're both correct. AP graders will grade the worst answer. All right, when I'm comparing them for the alternative, you notice it asked if there was a difference. So I don't know that one is bigger or smaller than the other. Oh, but Ms. Curtis, the smokers had the bigger number. Like, I don't care. We're not allowed to use data to make our decision. We go with whatever it asks about. It asks about a difference. That is not equal. All right, so if you were going to write it as the subtraction, you would write a not equal to. By the way, that's a really poorly drawn mu. I apologize. Should look like a U with an extra line coming down the front. All right, so those are my hypotheses. I'm going to move to step 2, which is to check my conditions. Same conditions we saw in the last chapter. We just need to verify that they're true for both samples. So the first one is random. It actually said that both groups were randomly selected. That's given in the problem, so we're okay there. The next one is nearly normal. Since we have two groups, we would need two graphs. A graph for the smokers, a graph for the non-smokers. Okay, that's really important. Two groups, two graphs. Okay, I know what you're thinking. You're thinking, Ms. Curtis, how am I going to graph this? They didn't give me any data. You're right. They gave us something really sneaky. It's like hiding in here. Right here. Both sets of data were roughly symmetric and had no outliers. They're telling you what the graphs looked like. That's kind of cool. So instead of drawing graphs, I'm going to skip that. We actually just get to say both sets of data were roughly symmetric with no outliers. What does that mean? That means it's nearly normal, so we're good to go. So nearly normal. Yay! If it makes you feel better, you can even specify that this was given in the problem. If they gave you data, you would be drawing 2 pictures, but they didn't. So we don't have any pictures. There's actually one more condition, and that's that we have independent groups. This is freakishly important. So important that if you do not have independent groups, you should not be doing a Chapter 24 kind of problem. Okay, I'm going to repeat that. That's so important. If you do not have independent groups, you should not be doing a Chapter 24 kind of problem. What do we do? We'll get to that. We'll come back to that. So what do I mean by independent groups? I mean that the smoker's heart rate is not affected by the non-smoker's heart rate. And you're like, well, duh. Yeah, but we need to specify that. What would an not independent groups look like? It would look like maybe like a before and an after of the same person. If I compared my own heart rate while I'm smoking and then my own heart rate while I'm not smoking, that is not independent because they're both me. Surely my heart rate in one situation affects my heart rate in the other because either it's a good heart rate or it's maybe really bad. So we'll see more examples of this to come. More to come. But you need to watch out and verify that the groups are independent. If not, don't you dare do Chapter 24, okay? You have my permission to skip the problem if it's not independent, at least until I teach you what to do. All right, so let's recap. We have written out our hypotheses. We have checked our conditions. We're ready to move on to our mechanics. So maybe a little bit tricky here, but to picture what's going on, here's our little T model. We suspect that the difference is 0. Yeah, see, we suspect right here that the difference, if we subtract, is going to be, 0. But we did not see a difference of 0. Check it out. We saw 80, and we saw 74. So we saw a difference of 6. That's not 0. So we're trying to determine how unusual is that to see a difference of 6. So that's what our t-score is actually going to measure. We observed 6. Since it's a not equal to, we're just as interested what would have happened if we'd observed -6. And we would compute our t-score this way. Whatever I observed goes first. I observed 80 minus 74. I observed that difference of 6. I subtract it from the mean, this right here, the mean of my t-distribution, and I divide it by the standard deviation. Okay, we keep changing standard deviation formulas, so let's check it out. This is printed on your pink formula sheet. It's when we have the difference of 2 means. You'll notice there are 2 different standard deviation formulas. This bottom one says that it's a special case when the standard deviations are equal. We don't ever know that the standard deviations are equal. We will never use this formula. You should never pool for t problems. Never, ever, ever. So we're going to use this top one. Notice we have this standard deviation squared for group 1. Now you can't read it anymore. We divided by the sample size for group 1. And then we have a standard deviation squared for group 2, divided by the sample size for group 2. All right, so I'm going to go ahead and plug those things in for my t formula here. Okay, it's a square root. Standard deviation for group 1, and it's squared over the sample size for group 1. What? Where'd you get those numbers, Ms. Curtis? Oh, standard deviation for group 1 is right here, 5. And it said there were 26 in that group. All right, the next one has a group of 32 with a standard deviation of 6. So that's where I'm getting all my numbers, just straight out of my story problem. And that's what it looks like. Now, I know that you could put that in your calculator, but it might get ugly and disgusting, and you might make lots of mistakes. So I'm going to show you my shortcuts, my secrets, in the calculator, of course. If we go to tests, we're doing what's called a two-sample t-test. I actually really want to write that down on this paper. Like, I want you to write it down. It's a two-sample t-test. Okay? That's what we're doing. If you can start to name these tests, it will make your life easier. All right, so two-sample t-test. I'm going to select that one. I don't have data in lists this time, so I'm going to actually highlight stats. The story problem actually gave me all the numbers. I just need to fill them in. Where you see all these subscript 1s, like 1, 1, 1, 1, 1, right here, 1, 1, 1, that's for group 1. Where you see all this 2, 2, 2, 2, 2, that's for group 2. So here we go. I'm going to plug them in. Group 1 had a mean of 80, a standard deviation of 5, and a sample size of 26. All of those numbers come from the story problem. Next one had a mean of 74, standard deviation of 6, sample size of 32. Oh, and then you'll notice there's more. This is where we specify our alternative hypothesis. Ours is not equal to. The answer to pooled is always no. And then we can calculate. I'm actually going to scroll down, point out all the things you don't need. All this stuff right here. Your mean, your standard deviations, your ends. Like, we already know all that stuff. So the most important items are actually listed first. And they're these top 3 lines. T, that's your t-score. That's this big ugly formula I was working on. You just write down the answer. P, that's your p-value. Don't forget to check all the way across. This is actually a very small p-value. And then df, your degrees of freedom. We're going to talk about that one in just a moment. So on my paper, I would include the answer to my t-score. I could draw some little arrows from my picture, or I can just write the word p-value. I don't know, that's a little easier. And I'm also going to write down that weird degrees of freedom from the calculator. All right, that's my work. Degrees of freedom. When we had one sample, we calculated it by taking the sample size minus 1. But now we have 2 different samples. We have a sample size for the smokers and a sample size for the non-smokers. And the new formula puts these 2 things together in a really gross and disgusting formula that I will not teach you, so you will just copy this from the calculator. All right. So which things are required? Please get to know the names of your test. Write down your t-score and its value. Write down the p-value. Write down the degrees of freedom. I don't care if you draw a picture. I find it helpful, but if it's causing you to have more confusion, then just skip it. Things in red, required. Okay, we're not done. We're not? No, we wrote our hypotheses. We checked our conditions. We did all the mechanics. We have a p-value, which means we can write a conclusion. Here's my conclusion. Since our p-value, remember that was that really small thing, smaller than my alpha of 0.05, that means I reject the null hypothesis. When p-value is low, reject HO. That means there is evidence that there is a difference in the average heart rates between smokers and non-smokers. I want to point out one really important word that I used, and it was average. This does not prove that every smoker has a different heart rate than every non-smoker. It shows us that on average, they are different in their heart rates. Really important. Make sure you catch that word. And that is our hypothesis.